Test.
No, I don't have time for
Need to do
Anything in specific? There it is. Have to hold it for a little bit. All right. Thanks, guys, for having me. And thanks, Ben, for making it happen. Ben knew I was going to be in town, said, hey, Mark's got opinions, why don't you come drop some opinions on people. My name is Mark Overholser. I am a systems engineer for Palo Alto Networks, and specifically I work in the behavioral analytics field, the behavioral analysis field, for the past 2.5 years, right? So I was on the customer side of things. I was, I worked my way up to being the team lead of information security at a medical supply manufacturing and distribution company in the Midwest. And then I went to the dark side. I went to go join a startup vendor called LightCyber, and did that for a couple of years, and then we got eaten by Palo Alto Networks, and I'm part of the Palo Alto Networks machine here. And so these, a brief word about bias, of course, I fully acknowledge that I work for a vendor. This, there's bias in how this presentation is, not necessarily because I'm beholden to the vendor, but because by working for a vendor, that affects like the information that comes across my desk, the things that I have access to, right? So I want to encourage you all not just to listen to me, but also to seek out other points of view, other opinions, right, about these sorts of things, and to, of course, think about them critically. I don't think it should go without saying, but I'm going to say it anyway. So first things first, what this presentation is designed to do is not to talk about any specific product, but to kind of talk about behavioral analytics more generically, and to kind of give you some of the things that I've noticed from my 2.5 years working in this space, to help you start to think more about it, to zoom out a little bit, right, and not just look at what the gardeners are saying and the foresters are saying and listening to that, right? So starting from the very beginning, what is behavioral analytics? And to me, what behavioral analytics is it's using data about actions to point out or draw conclusions about behaviors. And I've emphasized the words actions and behaviors there because they represent two different scopes when you're looking at this sort of thing, right? An action, to me, is individual in nature. Throwing a dart at a dartboard, that's an action. But behaviors are broader patterns. They're made up of individual actions, which are related to each other in some way. Playing darts is a behavior. You throw multiple darts. Each of those things is an action unto itself. But when you combine them, then you get this behavior of playing darts, right? So it's about zooming out. Behavioral analytics is. To me, also, behavioral analytics is not a distinct product category like firewall or antivirus or some of the others. To me, it is a technique that adds value to existing products or existing product categories, and by helping to increase automation. So a lot of people will come around and actually say, like, I got a behavioral analytics product. No, you don't. You have a product that does behavioral analytics. You need to know more than just it's a behavioral analytics product. It's very easy if somebody walks up to you and says, I have an antivirus product. You can make a lot of general assumptions about what that's going to do, right? How it's going to work, what the inputs are going to be. To me, that's a product category. But right now, there's a lot of hype. Obviously, there's also a lot of ambiguity that comes with this, the whole behavioral analytics category, because it hasn't crystallized, it hasn't solidified, and in fact, it's probably going to become like 15 different product categories in the course of the next decade or something. So the technique of behavioral analytics can be used to detect multiple things. One is behaviors which are only apparent when several distinct actions are considered together, when they're placed into the same context and considered together. That's what I talked about earlier about zooming out, right? Being able to consider several actions together to filter out the behavior. It can also be used to detect things that behave significantly differently than their peers, things that behave differently than their peers, and to detect things that behave significantly different than their past behavior. And these are all different kind of sub-techniques that work inside that realm, but they all play together. And we'll go through several analogies to kind of help you think better about these, right? So I have this one analogy that I really like to use. It's the rain analogy. And I relate this back to technology, right? We're familiar with signature-based detection solutions like antivirus, like an IPS, something like that. They focus on individual actions, they focus on individual artifacts, they focus on individual IOCs, because these things are easy to store and they're easy to compare in real time using pattern matching techniques that we have, in computer science. They work really well. So we think about things like antivirus, think about network intrusion detection or intrusion prevention systems, firewalls. They look at individual flows, individual packets, individual files, individual segments of a file, and they compare them against this database of artifacts and IOCs to look for matches. And it works very, very quickly, and it works very, very well. But if we take this and we move over into this rain analogy, this is like building a system that detects a raindrop and sends you an alert message. For each raindrop, you get a separate alert. That's not, there is some value in detecting those things, but then you have to hire an analyst, look at the patterns of raindrop alerts, and then determine, oh, is it raining? Okay, cool. Where is it raining? Is there a possibility that somebody just spilled a bottle of water on the lawn? And was it an isolated raindrop? Was it a light drizzle? Was it a torrential downpour? How bad is it, right? There's all these things that you have to do if you're dealing with all these individual alerts. So the value then in a system like that is that behavioral analytics becomes like a Doppler radar system. I'm sure that's a trademark somebody. And what it does is shows all the raindrops together, so it's easy to recognize the patterns. With behavioral analytics, you can zoom out, build systems that look at the raindrops and automatically determine where is it raining, how hard, and help give you that information so you don't have to manually do that, right? Help automate some of the analyst's work. Instead of looking for patterns, looking for deviations, the analyst can focus on validating and triaging and reacting to the alerts in a reasonable amount of time. Another example here, think of a simple TCP port scan. Now we're taking this and we're moving it actually into the technical realm, right? A TCP SYN port scan. Attacker sends several SYN packets, synchronized packets, to one or more destinations. This depends on if it's a horizontal port scan or a vertical port scan, right? Are you looking for services across many IP addresses in a range? Or are you looking at a specific IP address trying to figure out what services are running on it? Are you doing both? Are you scanning vertically across a horizontal range? So send a bunch of SYN packets and then observe the response or observe the lack of response and infer, is there a service running there? Did I get a SYNAC? Oh, there's a service running there. Did I get a reset? There's not a service running there. Did I not get a response within a certain number of milliseconds or seconds? That sort of thing. If you look at each of those connection attempts, there's nothing wrong with it. There's nothing, as long as the attacker is not setting the evil bit in their TCP headers, feel free to laugh, then there's nothing you can do as a defender to look at each individual connection and say, oh, that was an attack. It's only when you zoom out and you consider all of the packets together that you can then see the pattern, right? So that's similar to that RAIN analogy, but talking specifically about networking in that case, right? So it's only when you zoom out, look at the group of packets, look at them in the context of each other that you can determine that there's a pattern there. That's the only time when the behavior becomes apparent. You can't look at any individual connection and say, that was an evil connection. A different analogy, start talking about people and their behaviors. I call this just the first friend analogy, but it's time-based profiling. Say you have a friend who only eats sandwiches on white bread. Every time you see them eating a sandwich, they're only ever eating a sandwich on white bread. And one day, you see your friend eating a sandwich on wheat bread. This is weird. But it's only weird because every time you've seen him eating a sandwich in the past, he had white bread. You have to know the past history of that person's eating habits in order to know that that's strange, right? Other people who walked in the lunchroom and it was their first day, they would not think it's weird because they had no context from the past history, the past behavior of that person. I call this, or we in general call this, time-based analysis or time-based profiling. You have to know the past history of that entity, whether it's a person or a program or a network device. You need to know that in order to figure out if the behavior has changed suddenly. We take that, we move that into the technical realm. You can consider something like an attacker using PowerShell or PSExec or some other remote management utility to perform a credentialed, authorized action against another machine in the network, right? Say you have stolen credentials and you use PowerShell to PS remote to another Windows machine on the network and start up a process. authentication successful. Can't look for failed authentication there to figure out if it's wrong, right? There's no exploit being used. There's no IPS is going to necessarily detect that because there's not some malformed packets or anything like that. But a behavioral analytics engine could determine how likely this is to happen based on the past behavior of that source device, based on the past behavior of the person authenticated to that source device. You know, if it's a person who normally does this, who normally executes WMI or RPC queries against another machine on the network, then maybe it's not weird. But if it's a person who never does this sort of thing and then they start to do it, that's an interesting behavior, right? So that's it's similar to the sandwich analogy. But it requires learning from the past, comparing the current behavior to the past behavior. Again, time-based profiling. Friend analogy number 2, another sandwich analogy. I like sandwiches, I like food in general. Peer-based profiling. You have a friend, different friend. They eat sandwiches with the crust removed. We can all agree this is a valid life decision. There's nothing wrong with it, but it is still weird. It's weird because a small number of people do it, right? Those people are children. I'm sorry if anybody in the room likes the crust removed. Yeah, I'm joking with you guys. It's strange because the majority of people just leave the crust on. It's because it's delicious. So when you look for anomalies within a group based on the majority of the peer group's behavior, we call that peer-based analysis or peer-based profiling. And we move that into the technical realm again. Consider like an intruder compromises a machine within a network, and then they establish a command and control channel, HTTPS, to a newly registered internet domain. Brand new IP address, brand new domain, neither is blacklisted. You can't look at that and say that it's bad just by the IP address. If the IP address is not on any blacklists. Same with the domain name. If it's not on any blacklists, you're kind of hosed there, right? If the traffic is encrypted, either because it's just TLS encrypted or because there's some other encryption being used in an additional layer inside the application layer, you wouldn't necessarily be able to inspect and look for known patterns and say if this looks like the same structure, this field is here and this field is there. You can do that in some cases, but let's just for the sake of this argument, let's assume there's some encryption that prevents you from doing that. What you can do still is retrospectively compare the traffic against other traffic from the same network. So you can learn things like, what is the relative popularity of that destination? How many people in the network are going to that destination? How often are they going to that destination? How repetitive is that traffic? So you could look for things like repetitive traffic to an unpopular domain, and then you can flag that for follow-up, right? It could be a new command and control domain. But this requires looking at data about many connections from multiple devices in order to establish a baseline, because you need the baseline to look for the abnormality, to look for the abnormal behavior. So one connection individually does not contain enough information to locate the behavior. You have to consider all of the connections, and you have to consider all of the destinations. And then in the end, the behavior can be considered strange because the majority of peer devices do not do this. Unless, of course, the attacker compromises all the devices in your network, in which case, you need to update your resume. Another term that comes up frequently in this field is machine learning. And I'm not going to go deep down the rabbit hole here, but there's kind of at a high level, I want to make sure we're aware of a couple different types of machine learning that can be used. But in general, machine learning algorithms, it's a mathematical technique, right? And a computer science technique that allow computer programs to learn how to look for interesting things. The programs can learn how to look for them. Instead of having people teach them how to look for them, they can teach themselves. And there are kind of two major categories. Those are supervised machine learning and unsupervised machine learning. So the supervised machine learning category, we use labeled data sets where humans supply good labeled data for the algorithm to learn from. So the human supplies the data and says, this is X, this is Y, here you go, here's the goal, figure it out. And the computer program figures it out. So once the system is trained, it can then produce classifications for future data. Classic example here, malware detection engines using labeled data to detect new variants of malware strains. So you feed in a bunch of data and you say, here's all the malware, here's all the files that are not malware, here's your objective computer. I want you to label all of the malware malware, and I want you to label all of the not malware not malware. And you lose points anytime you label a good file as malware, and you lose points anytime you fail to label malware as malware. And then the computer figures out, I'm going to look at all these crazy attributes and just try to figure out what is the best way to do this. And then it comes up with its own set, and then you can apply that to other unlabeled data and get consistent labeling out of that too, right? So that's kind of how that works. Pseudo IPS as well. There are some variants of IPS software that will look for network traffic that looks like command and control based, again, on like inspecting the data inside the HTTP connection if that's available, right? Or looking at other things like interpacket timings and other things that I can't think of off the top of my head here. But supervised machine learning is useful in certain categories, but we need to be aware of its drawbacks as well. It's very, very rigid, very brittle. And that means that if anything changes after classification, those rules no longer apply. They no longer work. So if an attacker knows what the characteristics are for the training set, they can just change those characteristics. And then it doesn't work anymore. And we see this all the time with antivirus, right? It's that new variants don't get flagged, and then attackers realize, oh, if I just change this and this and this, and then change it every time, you never can build your rule set to catch me. Or once they detect that they're being caught, they can quickly pivot. And another drawback is that it only knows how to classify things based on things it has already been trained on. So totally new categories, totally new items that don't follow any of the previous traits or follow any of the previous trends, they will not be caught. And they will require a new training set, new data to be able to adapt to that, right? So it's very brittle, it's useful for classifying huge numbers of things, but you better hope that it's not adversarial, because adversaries can evade that very quickly and easily. Unsupervised machine learning, those techniques draw conclusion from unlabeled data sets. And the easiest to think about, of course, is anomaly detection. So the larger data set is used to create a baseline of normalcy, and then the algorithm looks for anomalies. And these are what we talked about earlier, things like comparing an individual's current behavior to their past behavior, and comparing an individual's current behavior to their peers' current behavior for the same time period to look for anomalies there. Anomaly detection is a big part of this. And this is much better able to adapt to changing conditions over time, as new baselines are calculated as time goes on, right? So you can keep calculating new baselines as you have new data, and you don't have to label the data. Machine learning, different approaches, different results, right? So these are the kinds of things you want to be considering if you're looking at somebody that's talking about that they're doing machine learning in their product. You want to be asking these questions. Who performs the analysis? What is being analyzed? Where is this analysis happening? When is this analysis happening? Because if you look, if you have something like a vendor performing the analysis versus the product performing the analysis, the vendor's performing the analysis, and they're doing it on objects, and they're doing it in their laboratory, they're doing it before deployment with the objective of creating signatures via supervised machine learning. What you get is more signatures. You get another known bad system, right? Known bad, where you have this thing that can classify stuff and tell you whether it's good or bad. Versus if you have a product that is doing the analysis, the product is doing it on your network, on your premises, or specific to you, and is doing it on activity, for instance, like metadata or logs, in a production system, during usage, not before deployment, but during usage. And with the objective of learning a baseline using unsupervised machine learning, what you get is a known good model. So it learns what's normal, and then can point out the abnormal. And I think that there's a case for having both, right? They complement each other. I kind of alluded to this earlier, but a quick sidebar about product categories. I mentioned that I don't believe that behavioral analytics is a product category unto itself. I'm going to explain why here, kind of give you a little bit more why I think this, what, data to back this up. In my opinion, product categories are defined by three things: context, a technique, and a goal. And you can also think of this as inputs, processing, and outputs. Context, technique, goal, inputs, processing, outputs. If you change any one of them, you get a new product category. Any one of them. And you can't always substitute one product category for another. Sometimes you can, but you need to understand that there may be a trade-off. Network antivirus and file system antivirus, two different product categories, I think we can all agree on that. And they both have antivirus in their name. But you can't substitute them for each other, right? If you have devices on your network that you can't run antivirus on, for instance, printers, right? So they still have computing in them, they can still be compromised. But you can't install McAfee on your printer. At least I can't. I failed every time I've tried. It can be useful to have a network antivirus to help protect those devices, right? Because you can't install antivirus on them. But if you have devices, say you relied on network antivirus, the problem you have then is you can't ever let your devices leave your network. You have mobile laptops on your network, and you're reliant upon a network antivirus to protect them. As soon as you let them leave your network, they're no longer within the comfort of your protection, right? So you can't substitute both. They complement each other, even though they both have antivirus in the title. So what I have here is this table where I'm talking about the context, the technique, and the goal, right? The inputs, how they're processed, and the outputs. And then I have the results in the product category on the right. So we start at the top. The context, within the context of network traffic, the technique being used is pattern matching, and the goal is to detect sensitive data. To me, that sounds like data loss prevention, DLP. And if we then change just one thing, we just change the context from network traffic to file system. So it's file system data, that's where we're working. We're still doing pattern matching, and our goal is still to detect sensitive data. Then it becomes a data classification product instead of a DLP product. And there may be some crossover into DLP, but it's a different category. Now we change one thing again. This time we're going to change the goal. So it's still going to be on the file system. We're still going to be doing pattern matching, but now the goal is to detect and prevent malware. It's antivirus. Totally different product category. Can't be substituted for DLP in any way. Again, changing one thing. Now we're still going to do pattern matching. We're still going to have the goal of detecting and preventing malware, but this time instead we're going to do it on network traffic. Then we get network antivirus. Still can't substitute it, right? Changing one thing again. Now we're changing our goal again from detecting and preventing malware to detecting exploitation attempts, but we're still doing it on network traffic and we're still doing pattern matching. Now it's network IDS. Change the goal again from detecting exploitation attempts to preventing exploitation attempts, and you get network IPS. Instead of intrusion detection, now it's intrusion prevention. Different product category. In my opinion, you can't substitute these things for each other. They can be considered complementary technologies, with, I guess, one exception, and that is that you can substitute network IPS for network IDS because it's a superset. But you see what I'm saying there, right? Like, anytime you change any one of those things, now it's a different product category. I never changed the technique in there, but you can substitute that, right? If we're working on network traffic, and we'd have to change our goals as well, but we could get to firewall, we could get to any number of other things, right? By just changing those things. Changing the technique would do the same thing. So keep that in mind when you're talking to vendors about something that does behavioral analytics or is behavioral analytics. What is the context? Where is that happening? What is the goal? To me, that's the most important. What is the goal? And what are your goals? So make sure those things are aligned. And then what is the technique? And there can be multiple techniques within a single product even, right? So say you want to dip your toe in the water here. How to evaluate a solution or how to select a solution? First of all, don't just issue an RFP for behavioral analytics, because it's not a product, it's a technique, and you'll get a lot of applicants for wildly different things. So save yourself some work, think about what your goal is, and then if you want to do the RFP thing, issue an RFP that clearly states your goal and what the limitations are for solving that goal, right? So what is the goal of your project? Is it to detect attacker behavior inside the network? Is it to detect malware in network traffic? Is it to detect malware on endpoints? Is it to detect fraudulent credit card transactions? Some of these things could benefit from behavioral analytics. Some of them cannot. So think about that and think about what is your goal. That's the most important thing. What is your goal? What is the problem you are trying to solve? And that's the thing that you need to clearly articulate to any vendor that comes across your desk, and then ask them how they would solve that goal. And if they can't, hopefully they will tell you that. And then you can say, well, thank you. I have time that I need to spend elsewhere right now. So each of these approaches requires different solutions. They are not interchangeable. So ask the vendor, what is the source of the data? Is it from network traffic? Is it from log data? Is it from endpoint agents? And then consider, more importantly, are you prepared as an individual and as an organization, are you prepared to maintain that source of data? Are you good at supplying network traffic to things? Are you a network-heavy organization? Do you have people with network specialty? Then maybe that's where your focus wants to be. Are you much better at maintaining log data? Are you good at aggregating log data from multiple sources and maintaining syslog servers and maintaining a data lake? Maybe you would prefer something that works from log data if you're better at that. Endpoint agents. Are you really good at deploying and maintaining endpoint agents? No, nobody is. Fewer the better, right? Ask the vendor what the goal is of their product, or what the problem is that they solve, and make sure that it fits your needs. I've said that a couple times, but bears repeating, right? If machine learning is used, ask the vendor where and when the learning takes place. Does it happen in their lab in advance? Does it happen in your network after deployment? And then consider, what are the pros and cons of that? How does that help or hurt you and your goals, and how that aligns? Ask whether they recommend you purchase additional ongoing services to review the output of the product. Most systems that use a heuristic approach require human review of the output. And that's because, I didn't really talk about it in the presentation, but I'll talk about it now. Normal and abnormal are things that a computer can infer, but good and bad are human constructs. There's extra human context that goes into making that decision. And so a computer can't decide that for you yet. When it can, we assume they will try to kill us. Whether a vendor recommends that you subscribe to their review service, and if they offer one, right? If they offer a review service to go through the alerts for you or with you, if they have that sort of service, that will tell you a lot about the level of expertise regulated, or the level of expertise required to investigate those alerts, right? If they have more services for going through that thing, chances are it might require more of those services to work. Because a lot of their customers probably asked for that because they got into it and then realized that they didn't have the resources to go through all the alerts. And the absolute #1 most important thing that everyone should be telling you is that if you're going to evaluate a product, you should try it on your own network, and you should try it under realistic conditions. Don't do it in the lab. Figure out a way to do it in production. Do it in a way that you don't affect production, but you should do it in a lab, especially with behavioral analytics. Like, it's a lot easier to stand up an antivirus or an antivirus replacement or a next-gen endpoint protection or whatever have you in an environment and feed in a bunch of malware samples that you've collected over the years that you've had infected machines in your network. That's easy to do in a lab, right? You can set up an isolated machine, feed stuff in, and see what gets caught, what does not, et cetera, et cetera. Behavioral analytics solutions require combing through lots of data. Lab systems don't generate enough data for it to be able to do the kind of math that it needs to do to look for anomalies, right? So keep that in mind. Try products in your own network under realistic conditions. There is absolutely no substitute for seeing it work in your own network. You will not be able to put it through the same kind of paces in a lab environment that you would be able to in a production environment. Short and sweet. there any questions? Are there any jokes you would like me to repeat? Yes, sir.
Wouldn't it be best or put it in a test environment?
Wouldn't it be best to put something in a test environment?
The behavior.
So when you say a test environment, what do you mean by test environment?
One step removed from production.
One step removed from production. So like a large copy of a production environment. It will depend, right? So the test environments that I have come from were test environments where users did not go, right? All the users went to production. So there's a potential source of data that if you ran a product in the test environment, you might be depriving it of some major source of data if there aren't actual production level users hitting that environment, right?
Well, you can control that by having representative users allowed into that environment.
You could potentially control it by having a representative set of users, like a sample of users going into the test environment. You could, but it would not be the same quantity of data.
True.
So it will vary, right, on a product by product basis. It will really depend on what inputs the product is looking for. If it's looking for in logs and looking at logs of application traffic from application to application within an environment, a test environment may be perfectly suited for this. One other thing to consider is that if it's not going to affect the production environment, say it's passively listening to things, and the outputs are not going to affect firewall rules or ACLs or things like that, then it may still be okay to put it in a production environment. In those circumstances, I would recommend that. But yeah, if you're gun shy about putting something in production, and it's, of course, really good to think about these things in advance, right? A test environment could be suitable, but it will depend. You really have to consider like what is happening in the test environment, and is that representative or comparable to what's happening in the production environment.
The end result is you get some kind of feedback in order to make an analysis of what you got.
Yeah, and it could be by putting it in a test environment, it could be like a phase 0, just to see, is it working well enough for us to think about testing in production, taking a larger risk.
Right.
Not necessarily taking a risk, but taking a slightly larger risk than putting it directly into production. Any other questions? Yes.
Mike.
Okay. Yeah, help me out here. I'm fuzzy on the details, but I heard a story about some guy that just got caught recently, and he would go into people's PCs, take control of their cameras, and watch them walk around the house. And he didn't do it on a wide scale. That was the kicker. He did it on a small scale, thousands of computers instead of millions, and he didn't let the thing go up like a virus and go wherever. So could behavior catch something that minuscule?
Could a behavioral analytics system?
So like, could a behavioral analytics system catch something that minuscule? It would be difficult not having the data to catch it, right? So I think the biggest problem with that sort of thing is if it's a person who's targeting individuals that aren't contributing their usage data to a central platform where it can be analyzed centrally, that's where you get into those problems, right? So like, could these techniques have caught it? Yes. Having the data, of course, but the question is, where is that data? If that data exists only within all of the individual PCs that are infected, then probably not. Now, if some of those PCs belonged to an organization, right, they infected that machine when that machine went home with a user, and that machine is reporting back telemetry data to an organization that has a behavioral analytics solution, yes, it potentially could have caught it. Now, in those circumstances, probably what happens is, having come from a blue team at an organization, is that when you find something like that, you say, oh, that's bad, we're going to reimage that machine, and then you never tell anybody, right? So that data doesn't make its way anywhere else. So these things have to be seen centrally in order for those patterns to be discovered in a way that they can help everybody. So kind of, we're still in this every organization for themselves mentality a lot, which doesn't really help everyone. So hopefully ISACs will start to become less stigmatized over time, and we'll start to share more information that helps. It's a good question though.
So he's referring to the aspect of the person from
Okay.
It is in a work environment.
Gotcha. And then law enforcement found out?
Yeah. But if when you infiltrate a business and it's some other vendor product and something kind of like this, that's the product.
Yeah. That's how it goes.
Any other questions? Another question.
Have you given this presentation to the Democratic National Convention?
Have I given this presentation to the DNC? I know I'm sharing your joke for the benefit of everyone else. No, I have not. I have not. I'm kind of hoping that this will get me an invite.
So I'm kind of going back to the beginning of the presentation. You were very specific in your differentiation between actions and behaviors being collection of related actions. So are those behaviors predefined in a lot of these analytic systems, or are they partly predefined and do the systems themselves, so the individual actions that start to create meta behaviors, correlate behaviors that you also start tracking?
From what I've seen so far, they're usually fairly predefined, but they will be like, okay, so sorry, I forgot to repeat the question for everybody. I made the distinction between actions and behaviors, right? Actions being small scale, individual things typically, and behaviors being collections of actions that are aggregated together into a behavior. And the question is, do these systems typically have predefined behaviors that they're looking for, or do they kind of train themselves to locate their own new behaviors? The stuff that I've seen so far is, we're still kind of early on in this space, right? That it's mostly predefined behaviors. And the hard part is you want to catch behaviors, but you also want to not have a lot of alerts, right? Because the more alerts you get, the more you got to sift through. So right now, this space is kind of looking for specific behaviors and keeping it to behaviors that are interesting, generally interesting for analysts to look at. And I think it'll start to expand as more people ask that sort of question, or they kind of get bored of the alerts that they're getting, or they'll start to ask, like, how can you show me about other things that are happening in my network?
It's kind of like the supervised machine learning, where if you were looking at actions and letting the machine say, okay, we've got all these things happening, it's known that happening, and you can see the correlation now that all these things happen, and then you have the human review that and say, yes, that was definitely a bad action, which also behavior is really strange.
Oh yeah, that's a good. Yeah, that's a good. You could create a feedback loop between the machine and the human, and say, and let the machine generate suggestions, right? And say, this looks like a new kind of behavior. What do you think about it, human? And have the human say, no, I don't care, or yes, I think that's interesting. And that could create a feedback loop to start to train the machine to locate new things. The trade-off there is then you have to have your analysts look at more of those things and do that training. Which is not necessarily a bad thing, but it can cause fatigue, right? If they have a lot of things to look through. So again, it's all trade-offs, right? Engineering is always trade-offs between one extreme and another. Yes?
What if a company were to purchase a product and the bad actor is already there?
Oh, yeah, good question. What if somebody gets a behavioral analytics solution and they put it in their network, but there's already a bad actor on the network? My go-to there is we talked about the two different types of analysis, the time-based analysis and the peer-based analysis. And the time-based analysis gets fooled by that, right? Time-based analysis, if the learning period there's a corrupt behavior during the learning period, then the time-based analysis engine learns the bad behavior as normal, right? It never successfully flags it as an anomaly. That's why you want to do both. That's why you also want to do the peer-based analysis, so that the infected machine or infected machines don't behave like the other users and machines on the network, right? So they stick out like a sore thumb, unless of course they're all infected. And then and if you haven't noticed it, then you have big, big problems, right? Other questions? All right, well, thank you very much.